Great. Well, hey, everyone. Welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I'll be your host for today. Apologies for the short delay. We have two events going on right now, and we had tech issues in the other one, but I think everything is nice and sorted. So we are into October. October is our space exploration month, which is always a ton of fun here at Exploring by the Seat of Your Pants. We're hanging out with astronauts, scientists, engineers who are helping us explore beyond our planet into the solar system, look out into our universe, and then turn a lens back on Earth and look at our planet in ways we never could before. So exploringbytheseat.com is where you want to head to find all the live events we have coming up all month long. Of course, we'd love to see your classrooms joining them. And then we are going to spend a little time today learning a bit about the James Webb Space Telescope and the cool things it's been finding. So we're going to have Nathalie Nguyen-Quoc Ouellette joining us today, an astrophysicist, science communicator, and lifetime lover of all things space. She's currently the deputy director of the Trottier Institute for Research on Exoplanets and the Mont-Mégantic Observatory at the University of Montréal. She's also outreach scientist for the James Webb Space Telescope in Canada, collaborating with the Canadian Space Agency. Let's get Nathalie in here with us live. Hey, Nathalie, how are we doing today?
Good. How's everyone doing?
Good. It's great to have you live with us. It's been a little while since we've connected, but one thing we've definitely been seeing in the news is amazing images coming back from that space telescope.
Yeah, absolutely. So I've been taking a little break. I had a baby a year ago, but my space baby has been very busy and I've been keeping an eye on it.
Very, very cool. Well, to the classrooms who are tuning in via YouTube, don't be shy. Use the chat sidebar. Let us know where you're tuning in from. Get your questions ready for Nathalie. Our camera classrooms, we're going to come bug you shortly for some of those questions. For now, though, Nathalie, I see your presentation backstage. I'm going to bring it in and let's let you take over for a little bit. Sorry. I have to remove my screen share to put yours in. There we go.
All okay, right, perfect. Okay, so I am so happy to be back. This is actually my first presentation since I came back from mat leave, and we're going to be talking about the cosmic wonders with the James Webb Space Telescope that I mentioned is my space baby. So a really wonderful mission. So I'm an astrophysicist or an astronomer. It's sort of the same thing. And what we study when we're looking at the universe is, of course, objects in space, but we need to use the light that these objects are creating and that's shining through space. And of course, there are all the colors of the rainbow, which is the kind of light that we can see as humans, but there are lots of different kinds of light that we can study as astronomers. So here you have what we call the electromagnetic spectrum. These are all the different kinds of light we can study. These include radio waves, infrared light, visible light, which is the colors of the rainbows that I mentioned, ultraviolet X-rays, gamma rays. So astronomers can look at all these different things, but only the visible light is visible to the human eye. So in order to look at the other ones, we need to use special tools called telescopes. And the telescope that I use a lot, and a lot of the people that I work with, is called the James Webb Space Telescope. So an awesome mission that's been in space now for several years. I have been on the mission for 6.5 years now. And it is a mission led by NASA. So NASA is sort of like the big player in space agencies. But what's exciting about this one is it is an international collaboration. So we have the European Space Agency, all of Europe participated, but here in Canada, we're very excited. I'm in Canada. The Canadian Space Agency was also a partner on this mission. So I mentioned all the different kinds of light that you can look at using telescopes, and the James Webb Space Telescope looks at infrared light. So it's invisible to us, but our telescope can look at this kind of light. So here we have something called a nebula. One of my favorite objects in space is called the pillars of creation. It kind of looks like a hand, and this is where stars are born. So this is the pillars of creation as seen by the Hubble Space Telescope, another really amazing telescope up in space that looks at the same kind of light that our eyes can see in the visible light. Now, if we look at exactly the same spot in space using the Webb telescope in infrared light, you can see very different things. And that's because there is magic with infrared light. It's science, but it feels magic. Infrared light can actually look through gas and dust that is in space. So even though Hubble in the visible light sees this very dusty area, with Webb in the infrared light, you can see through that dust, and all of these stars finally appear, and you can see these stars being born. So that is one of the reasons why we want to look at infrared light. You can see through this gas and dust in space. So I'm the outreach scientist for the Webb telescope. I have had the pleasure of meeting my space telescope before it was launched into space. It is huge, it is gigantic. It's about the size of a 3-story house. The big aluminum foil piece that you can see here is the biggest piece, and it is what we call a sun shield. It protects it from the sun, and it's as big as a tennis court, so really gigantic. So I love this picture. It reminds me of when I visited my telescope, but I often also like to show this picture of me. A few years ago, I made a Halloween costume that was the James Webb Space Telescope, and I wore it and gave out candy. So this is sort of how I like to do outreach. I like to inject my personality, my sense of humor, and show that scientists are sort of just humans, and we are all very different and quirky and have our different interests, and like to include that in our science and our outreach as well. So not only is the James Webb Space Telescope a wonderful science tool, it is also a technological wonder. It's the largest space telescope we've ever sent up into space, and that caused quite a challenge when we were building it because we didn't have a rocket that was big enough to fit the whole telescope when it was in its normal operating configuration. So what we needed to do is be able to fold the telescope up on itself and stuff it into the rocket to launch it. So here you see what happens after we launch the telescope into space. You have a counter at the top, and it's telling you what's going on over the span of several days. So the telescope is being launched from Earth. It's cruising by the moon, and it is going to a final destination of 1.5 million kilometers from Earth. And as it's doing that, as it's moving, it needed to unfold because it couldn't look at space when it was all folded up on itself. So here you can see we're at day 4, day 5 now. It is opening up that sun shield that I mentioned. So one thing about infrared light is that it's very, very sensitive to heat. And one thing that we know about the sun, it is very, very hot. So if the sun is hitting our telescope, it will heat up the telescope, and the telescope itself will start shining in infrared light, which we don't want at all. So this big giant sun shield, which I mentioned is the size of a tennis court, always protects the big golden mirror of the telescope and the sensitive science instruments from the sun. Now here you can also see in a moment, you have the big mirror that is going to unfold on the telescope. So this mirror is actually made up of 18 smaller parts, smaller segments, and the whole thing is about 6.5 meters wide. So really, really huge. And the bigger your mirror, the more light you can accumulate from things that you're looking at in space. So that makes it really, really powerful. You'll also notice that the mirror is coated in gold. Now, that's not only to look pretty, that's because gold is very, very good at reflecting infrared light. So we had to invent all kinds of new technologies to make this telescope the technological wonder that it is now. I mentioned many different space agencies worked on this, and Canada contributed a double instrument aboard the telescope. So here you have this sort of golden box, and on top, you have what we call the fine guidance sensor, and it's basically just a camera that allows the telescope to track objects in space. So it's not a science instrument, but it allows the telescope to really lock onto a target. So it's really, really critical for the mission. It's kind of like the eye of the telescope. And on the bottom here, you have our science instrument, which we call NIRIS. It's a combination of a camera that can take science pictures and another tool that we call a spectrograph that can take light from the objects we're studying and break them down so we can get even more information about them. So in Canada, the main partners was the University of Montreal, where I work, the Canadian Space Agency, another government agency called NRC, and a company called Honeywell. So all together in Canada, we had hundreds of people working over several years to deliver this double instrument to the mission. Now, one of the things that I love about the James Webb Space Telescope is that it is a telescope that can do lots of different things. Some telescopes focus on only specific missions or specific kinds of objects, but Webb has something for every kind of astronomer, essentially. So we can look at alien worlds. Those are planets that are within our own solar system, but also outside of our solar system, called exoplanets. And I'll go into those a little bit. It can look at the life of stars. Stars are born, they live a certain amount of time, and they die. And a lot of their phases of life are in very, very dusty environments. So Webb and its infrared light is really the perfect tool to study these. It can also look at galaxies, these big groups of billions, hundreds of billions of stars and gas and dust held together by gravity. And one of the main goals of Webb is to understand what was going on at the very, very start of our universe, just after the Big Bang happened. So I'm going to go over a few of the big discoveries that the Webb telescope did over the last few years. Some of my favorite. If I had to go through every single discovery, we would be here all week long. So these are some highlights. So just recently, a few months ago, the Webb telescope actually discovered a new moon around Uranus. So, we have other planets in our solar system. We have 8 planets total. The Earth, of course, has the moon, but most other planets also have moons. In fact, the gas giant planets like Jupiter and Saturn, they have hundreds of moons. Now, Uranus, up until now, had 28 moons that we knew of, but the Webb telescope is so powerful, it was actually able to discover a 29th moon this summer. So you can see it right there. It's circled and there's an arrow pointing at it. And it is a very small moon, just 10 kilometers wide. That's why we haven't been able to spot it before. You need really strong tools to be able to spot little moons like that. Inside of our solar system, we also recently had another mission, very exciting, called DART. And one of the goals of DART was to see if we were able to take a spacecraft and hit an asteroid with it so that we can change the trajectory, the direction of that asteroid in case it was going to hit us. So some of you might have seen some movies, some are a lot older than you, called Armageddon, for example, where we have an asteroid that's coming towards us. It's going to hit the Earth, which is not really great. Just ask the dinosaurs. They didn't really like that. So we want to see if we can protect Earth from an asteroid hit. So NASA sent out a mission. They took a satellite and they hit this little asteroid that was actually orbiting around a bigger asteroid, and it was able to change its trajectory. That means that we are sort of building up the tools to try to protect our own world. And after that hit happened, all the telescopes on Earth and in space turned towards that asteroid to continue taking pictures and studying how that hit changed the trajectory of the telescope. And that included the Hubble Space Telescope that I mentioned and the Webb Space Telescope as well. So when you had the big satellite hit the asteroid, it didn't just change the trajectory, a bunch of dust also sort of exploded off the surface. And we were able to study that dust from afar, the light passing through that dust, and study what the asteroid was made of, looking at that dust. So one of the challenges that Webb had in studying this asteroid hit is that asteroids are moving through the sky a lot faster than stars or really distant galaxies. And for this particular mission and this image that it took, the Webb telescope had to track the asteroid at a speed that was 3 times faster than what it was designed for. But luckily, on our team, we have really, really good engineers that were able to change how the telescope works a little bit so it could track that asteroid hit. So we're doing our part in trying to protect Earth from asteroids. Now, I mentioned exoplanets. I work at a research institute that studies exoplanets, and an exoplanet is simply an alien world, a planet that orbits around a star other than our sun. That means it is outside of the solar system. So it's not the planets in our solar system. And these are very, very hard to observe. Actually, just yesterday, we celebrated the 30th birthday of the first exoplanet we ever discovered. So it is a very recent, very new field of astronomy that we've been studying. And maybe you've seen pictures like this of exoplanets before, but these are drawings because it is basically impossible to take pictures like this of an exoplanet. They are so far away and much smaller than the stars that they're orbiting. So, in order to spot an exoplanet, we have to get a little bit clever. And one of the ways that we do this is by staring at a star. And if we see that the brightness of the star goes down, there's a good indication that something passed in front of it, probably a planet that's orbiting around it, and blocked some of that light. So, by studying the star, we can detect these exoplanets. So, we've been able to do this with the James Webb Space Telescope, not only spot the exoplanets, but study them in bigger detail. And one of the things we're trying to find are worlds that kind of look like Earth and could potentially hold alien life. So, one of the most popular systems that we are studying with the James Webb Space Telescope is called TRAPPIST-1. So it's about 40 light years away, so relatively close, but we wouldn't be able to just hop on a spaceship and get there tomorrow. It's still quite far away. And this planet system has 7 planets that look a lot like Earth. They're all rocky. There are no gas giant planets on the system, and they're about the size of the Earth. So here you have lots of interesting targets to maybe find alien life. But it's not enough to just find a rocky world. You want to be on a world where the temperature is nice and warm, not too hot, not too cold, so that if there is water on the surface of that world, it can be in liquid form. Because we know liquid water is very important for life here on Earth, and it's important for you and me. We need to drink lots and lots of water. So that zone where the temperature is just right in a solar system is called the habitable zone. So TRAPPIST-1 actually has 3, maybe 4 planets in the habitable zone. So that's really exciting. So we've been spending lots of time studying all the planets in the system, but especially those 3 there. There is a challenge though with the TRAPPIST-1 system. Excuse me. And that is because it has a star that is very active compared to our sun. Our sun is a quiet star, but this particular star has lots of things, including sunspots. So here you have an animation that shows you what happens if a planet passes in front of the star while there are sunspots on its surface. I'm just getting over a bit of a cold, I'm sorry. So you can see that we have weird little signals that are happening because there are spots on the surface. You can also have big there we go. Big eruptions at the surface of the star. And these can actually be very damaging if there is life on the planets nearby. So because we have to study the star to study the planet, it's very important to understand what's going on with the star. But TRAPPIST-1 is very complicated. So we haven't been able to find alien life or even liquid water on these worlds just yet. There are different kinds of planets we can study with the James Webb Space Telescope, however, and one of them is very promising. It's called K2-18b, and this one we think might actually have quite a bit of water on it. We call it an ocean world because we think it's covered with a thick liquid ocean. Maybe there's water, maybe there's other types of liquid on it as well. And what the James Webb Space Telescope can do is look through the atmosphere of these different worlds and find the different molecules, all the different types of elements that are inside the atmosphere of these worlds. So here we have different elements like methane, we have carbon dioxide, which is what we breathe out when we're breathing. And there's one kind of chemical in the atmosphere of this planet called dimethyl sulfide. You don't need to understand what that is. We call it DMS. But one thing that's interesting about DMS is here on planet Earth, the only thing that can produce DMS is life. Life in oceans called algae. So that means that potentially this world might have alien life. But there's lots of different theories we need to test first. So we need to test these different things before we can really dive into saying there is alien life on this planet. We can also look at stars. I mentioned that we can look at the whole life cycle of stars. So stars are usually born very, very violently. Here you have one star that is being born and it is blowing out two huge jets of energy on either side of the star. It's so big, in fact, that the whole thing spans 8 light years across. To give you a bigger indication of how big that is, this orange circle that you see here is about the size of our entire solar system. All the planets, all of the comets, really, really far out. And you can see the jets go much, much farther out than our solar system would go. So the James Webb Space Telescope can study the birth of stars. It can also study how these stars are being born in a bigger environment, places that we call stellar nurseries. So one of the first images that we ever released from the James Webb Space Telescope is called the cosmic cliffs. So here we were able to create a 3D video that lets you dive through the cosmic cliffs. And all of that gas that you can see there, this is where stars are being born. That gas is sticking together and is creating new stars and new planets around those stars. And with the James Webb Space Telescope, we can even sort of peek into that gas because of infrared light and look at these stars being born. And we're able to turn it 3D because we have information about the distance between us and these different objects. So really, really beautiful. And finally, we can also look at the death of these stars. So when a star dies, depending on its size, it will usually sort of puff up really big and blow out its outer atmosphere and create what we call a nebula, a planetary nebula. Or it can explode in a big supernova explosion and sort of like spray all of its insides all over and cause what we call a supernova remnant. So on either side here, you have planetary nebula, and you can see we can have different shapes. And in the center, you have the leftovers after a supernova explosion. So the James Webb Space Telescope can look at all these different things. We can also look at galaxies. So galaxies usually are in groups, sometimes in huge groups of hundreds or thousands of galaxies together, and they can sometimes smash together. So here you have two galaxies that are colliding and that are going to create one bigger galaxy. Here you're looking at what we call the near infrared. So even within the infrared light, we can look at different types of infrared light. But if we look at mid-infrared, a slightly kind of different infrared light, you see different parts of the galaxy start to shine. So it's sort of looking at the skeleton of the galaxy now. And here, finally, you have one of the first images we ever released. There are thousands of galaxies in the single image that is a tiny part of the sky. If you took your hand and you put it at the end of your arm, it is about the size of your thumbnail that is on the sky. It is a grain of sand, actually. Sorry, it's a grain of sand at the tip of your finger. That is the size of the picture on the sky. And there are thousands of galaxies in here, and they all look very, very different. So as you can see, we can observe lots of different things with the James Webb Space Telescope. So it is a wonderful tool for astronomers, and we hope it will keep doing lots of cool discoveries for years to come. Thanks.
All right. Good stuff. Nathalie, thank you so much. I just can't get enough of those photos. That photo of the colliding galaxies is pretty amazing. And I can't tell you how honored we are to be your first presentation back from maternity leave.
Yeah, I'm sorry about my cough. There's lots of viruses at daycare we're learning, and we're getting all of them.
No, don't even think twice about it. It's great to have you with us. It's great to see these amazing images and how we can look so deeply out into our galaxy and beyond. It's pretty amazing. Let's get some voices in here. Let's go to Mrs. Evan Bergen's crew. Grade 6 is hanging out with us. How are we doing today?
Good.
Good. Let's get a couple questions.
Yep, we got Hudson coming right up here. Do you know how many stars are in the outer space?
Okay, in all of outer space, I'd have to do a little bit of math. We think there's over 1 trillion galaxies in all of outer space, and each galaxy probably has a few hundreds of billions of stars. So that would be a lot of zeros. But one way that I can describe it to you is we think there are more stars in the entire universe than there are grains of sand on Earth. So a lot is my answer.
Okay. Do you think they're going to create a new planet?
Can you say that a little bit louder?
Do you think they're going to create a planet?
So who do you mean by they? Like if we can create a planet?
Like the space?
Yeah, so planets are being created all the time. And actually, we're able to take pictures of planets being created with tools like the James Webb Space Telescope. But there's also a really cool telescope in South America called ALMA. And it's really good at taking pictures. So planets are formed inside of disks with lots of dust inside. At the center, there's a star being born. And in the disk, you have these clumps that are getting bigger and bigger and turn into planets. So we can actually see planets being created every day in space.
Oh, let's do one more. Sure.
What will you call the next planet if we find alien life on it?
So probably whichever planet we find alien life on probably already has a name. Because all of these planets, they already have names. If you discover a new planet, you can name it. But astronomers have like a system to name planets. So you can't just name it like Bob's planet when you discover a planet. Usually you have to name it after the star. So for example, TRAPPIST-1 is a star that I mentioned, and it has 7 planets. So the name of its planets are TRAPPIST-1b, TRAPPIST-1c, TRAPPIST-1d. So it's sort of like having a guy named Joe, and then he has a son, and then we call the son Joe Jr. But how do we name the star? Usually the star is named after the telescope that discovered it. And then the number is like which, on the order of the stars that it was discovered, what number it is on that. There's different systems like that. Sometimes it can be related to the constellation it's in as well. So there's like a strict system to name these planets. I can't name a planet anything I want.
Thank you.
All right. Well, hold on to those questions, grade 6s. We're going to come back your way in just a second. I'm going to grab one from online. Miss Wong's crew's with us. They want to know the maximum range of the telescope.
So that's a great question. So I'm assuming they mean sort of like by distance. So it's kind of hard to talk about distance in terms of kilometers or really distance. We're looking at things that are so far away that what we usually do instead is we say how far back in time we can see with the telescope. Because if you didn't know, telescopes are also time machines, because it takes an amount of time for light to travel from wherever it was created to here. We're looking at light that is kind of old. So that's why we say we're looking at something 1 billion light years away. That means that it took 1 billion years for that light to get here. And what we're looking at, the image, is 1 billion years old. We're looking at that object as it was 1 billion years ago. So the universe is about 13.8 billion years old. At the start, we have the Big Bang. With the telescope, we've been able to look at objects that were created, or as they were, about 250 million years after the Big Bang. Now, obviously on Earth, 250 million years is a really long time, but in the history of the universe, that's not very long at all. If we put the Big Bang on January 1st and we put present day, about now, 250 million years after the Big Bang is like January 6th. So we're still like in the first week of the history of the universe. And that's how far back we can see with the James Webb Space Telescope. So really impressive and record breaking.
All right. Thanks for that great question. Caesar is joining us all the way in Nicaragua, and Caesar is very curious about the birth of stars. So I think he's curious about the time scale for how long that takes.
Yeah, so for stars to be born, it does take quite a bit of time. We're talking about like a few million years. And then over time, a star will go into what we call the main sequence, which is sort of like the adult phase of the star. And that can last billions of years. So, for example, our star, the sun, is sort of like in its main sequence in the middle of its life, and it's about 4.5 billion years old. But it takes a few million years to form a star initially.
Okay, let's get Miss Nielsen's crew in with us. There they are, some grade 4 or 5s. How are you doing today?
Oh, they're muted. There we go.
There we go.
Okay, Forrest. Wait. Forrest was. So you have to go down here.
What is the farthest planet you've seen?
What's the farthest planet I've seen with my own eye?
Well, just like any, like with a telescope, like any sort of material.
But me personally.
Mhm.
Okay. So I have been able to see planet Neptune with a telescope, and it didn't really require like a huge telescope. Where I went to university, I ran the observatory there, and we had a telescope that was about 40 centimeters big, and I was able to see Neptune with that telescope. But it wasn't like a big, nice round ball, and you could see its clouds and everything. It was like just a little dot. So these planets are very, very far away. And then when we're taking like these nice pictures of them, it's because we sent a satellite that just went right next to them. So they just look like little dots, but Neptune is the furthest that I've seen with a telescope.
Thank you.
Lily, come on up.
Have you found any sort of life in space?
Not yet, but we're looking very, very hard. So I mentioned trying to find alien life on exoplanets. We're trying to do that, but even inside of our solar system, there are planets and also moons that are very interesting for alien life. So maybe you know about the rovers that are on Mars. We're trying to find alien life there. It's more likely that life existed a long time ago on Mars. So we're trying to find evidence of life from back then, like maybe fossils. But we think that maybe there are some watery moons that go around Jupiter and Saturn, and they might have life right now because they have these like really nice oceans of liquid water where life could exist. So we haven't found any proof of it yet, but if I had to say, I think maybe in the next 10 or 20 years, we're probably going to find our first aliens. But it's probably going to be like bacteria. So very, very small and simple.
Have you discovered any other new secret planets?
Secret planets. So in the solar system, there's actually a planet that we've named Planet 9, or some people call it Planet X, and we've never been able to take a picture of it. But when we look at the orbit, the way that Pluto moves around and the way that some of the objects on the outside of the solar system moves around, we have a pretty good clue that there's something pretty big out there that's sort of like pulling things around through the force of gravity. So we think there is sort of a secret planet 9 in the outside, just on the border of the solar system. It's like it would probably be a little bit smaller than Neptune, but because it's so far away, we haven't been able to take a picture of it. We're looking really, really hard for it. But it wouldn't be the first time that we saw the effects of a planet before we actually saw the real thing. Neptune, we actually guessed that it existed before we took a real picture of it. So it's the same thing with Planet 9. So I'll let you know if I find the secret planet at some point.
Okay, thank you.
Can I go next?
Are we allowed to have another one?
Yeah, let's squeeze in one more, and then we'll go back to YouTube, and then we'll visit Ms. Van Bergen's crew again.
Everyone else sit.
What's the planet with the most moons?
In our solar system, the planet with the most moons is Saturn. And I can't remember the exact number, but it's something like 270 moons. So there's like a lot. Can you imagine having 270 kids running around you all the time? And actually, some of its moons are inside of its rings. So the rings aren't like one big solid piece. They're sort of like made up of all these little rocks and snow and ice pieces. And so you can have a moon that's moving inside of the rings of Saturn. So Saturn's got a lot to manage. It's got big rings and about 270 moons.
Thank you.
All right. Great questions, crew. We'll try and visit your class one more time before the end. Back to YouTube. I've got a question about the lifespan of the James Webb Space Telescope. How long do we think it's going to be sending back amazing images?
So that's a great question. And when we launched the mission, we were really hoping for, okay, 5 years was like the minimum. If we didn't hit 5 years, we would consider it, we kind of failed our mission. We were really hoping for 10 or 11 years. But the thing that really limits how long the mission can last is how much fuel is on aboard the telescope, because most of its science instruments are powered by solar energy, but we need to change its orbit, its trajectory every few weeks, because the sun is constantly blowing on it and making it sort of like move from where it's supposed to be. So we need a little bit of fuel in order to do that, and that's like the thing that limits the mission time. But the launch went so well. We saved a bunch of fuel during the launch and when it went into its initial orbit. Because of that, we more than doubled the expected lifetime of the mission. So we think that the mission could go on for like a total of 25 years maybe. We're only about 3.5 years in now. So we got lots of time ahead. Of course, maybe some of the instruments will start breaking down before that, but at least in terms of fuel, we still got lots of time, over 20 years ahead of us.
All right, let's get Mrs. Evan Bergen's crew back in here and see if they have another question or two for us. I think they might.
Go right up to the, yeah, go over a little bit.
Is it possible to take an image of like a pretty big exoplanet? Like an exoplanet does like a gas giant?
That's a great question, because yes, it is very frustrating that these exoplanets are so far away and we can sort of only look at them through the effects they have on their stars. We can take an image of certain exoplanets. We've been able to do it with like a handful of them, but it has to be in very special conditions. They have to be big, like you said, really big. We're at the point now where we can look at exoplanets, take a picture. If they're as big as Saturn or Jupiter, at the very start, they have to be like 10 times bigger than Jupiter, really huge. They also have to be quite far from their star, because stars are really bright. So imagine if you like, I was asking you to like, look at this tiny little firefly that was like going around a big giant street lamp. It would be hard because a street lamp would be like so bright, it would like sort of blow you away. So if the planet is farther away from the star, it's easier for us to take a picture. But they don't look like the drawings that I showed you. They still just look like shiny dots in space. But for a few of them, we can take a real picture of the exoplanet.
How many more questions do we have time for?
We love questions. So if you have one or two, you can send somebody up. Absolutely.
Get up there, Cole.
No, 3.
What is the biggest solar ray that has ever been recorded by James Webb?
Like, oh, so interesting. So you're mentioning like solar rays or solar flares. If we're talking about inside of our own solar system, one of the only objects that the Webb telescope actually can't look at is our sun. Because if it looks at our sun, it's no longer protected from sunlight. So then it gets all hot and it starts glowing in the infrared and all the instruments break. So it can't actually study our sun. If you're talking about sort of the other stars, how big those flares are, I wouldn't be able to tell you which one exactly. But if you're like counting all the big violent things that can happen on stars, the Webb telescope can look at a star exploding itself. So that's a pretty big flare coming from a star when the star goes supernova and explode itself.
Mm-hmm.
Thank you.
All right, let's grab, a double question. Here we go.
So our question is, so last week I heard like there was a snake on a planet, and I wonder if it was true. She wonders too.
Oh, do you remember what planet you heard?
I think it said Mars.
Mars. Okay. I can tell you right now, we haven't found any snakes on Mars, unfortunately. But a few weeks ago, we found something on Mars, one of the rovers on Mars, Perseverance, inside the rocks. It found some like weird patterns that we call leopard spots. We didn't find any leopards either. No leopards, no snakes. But in the rock, it found a pattern in the rock, which tells us that maybe life billions of years ago could have created these patterns. Now we're not talking about like a footprint. We're talking about like bacteria having chemical reactions in the rocks and creating these different things. So maybe that's what you heard. And sometimes when we make a discovery in astronomy and it goes in the news and we sort of lose track of the message, we can end up with headlines that say things like, we found a snake on Mars. But unfortunately, no snakes on Mars just yet.
I asked this because like there was like an actual space footage of like a thing, like a snake shape. So I wonder if it was true. But, yeah.
It was just like a snake shape, or like a real, like you saw the snake?
Like it was moving. Like it was like from.
Oh, it was moving. Yeah, I'm not sure what that was, but it definitely wasn't on Mars.
Okay. Thank you.
All right. Thanks, grade sixes. You know, it's getting really hard right now, too, with AI videos that people are putting out. So it does get kind of hard to they're getting so good now that sometimes you can see some videos people put out to try and trick people. So I think that's probably something we'll have to think about. And this morning we talked to our friend Robbie, who works at JPL, who talked about how AI is changing space exploration with new designs, looking at more data, running spacecraft and operating them. So pretty cool the way AI can help us out, but it can also trick us. And we always have to be a little bit more careful, I think.
Yeah,
okay,
absolutely.
Nielsen's crew, if you would like to ask.
Okay.
Does the space ever end? Is there a wall?
Oh, that is a great question. And if you find out, please let me know. So you're asking sort of like what the shape of the entire universe is. And the answer is we don't really know, because we haven't been able to send a spacecraft out that far. In fact, the spacecraft we sent out the farthest ever, they just recently left the solar system. They haven't even been able to get to like the nearest star. We can use telescopes to try to look really, really far, but even with a powerful telescope like the James Webb Space Telescope, we can't see the edge of the universe. So we don't know what the shape is. It could be infinite, or maybe there's like a weird boundary, or it could be like a weird thing where like if you keep walking in one direction, you don't hit a wall, but you end up like walking out of the other direction. So it's like this infinite loop. It's like a weird shape that we can't even sort of like imagine with our human brains. So the answer is we don't know what the edge of the universe looks like.
Thank you.
What was your first telescope and what does it do?
My first personal telescope when I was a kid, I don't even remember the brand. It was like a pretty small telescope that my dad bought. It had like a mirror that was maybe like 10 or 15 centimeters big. And I live in Montreal. We have a lot of what we call light pollution here in Montreal. So it's hard to see lots and lots of stars. But I remember using that telescope out in our front yard and looking at Jupiter. So you could actually see the big red dot on Jupiter with the telescope. And I could see some of its moons as well. So it has 4 really big moons. And you can see they change positions overnight. They're just little bright dots. But I would look at Jupiter and its moons night after night and like see how things were changing around. So that was really cool.
Thank you.
You got to face
Okay.
it.
So what would happen if the sun moved too far, like an inch too far away from us, or an inch too close to us?
So the sun is not actually perfectly still at the center of the solar system because it has, of course, lots and lots of gravity, which is why all the planets stay stuck to it. They're orbiting around it. But planets have their own gravity as well. And Jupiter, in particular, our biggest planet in the solar system, it's doing quite a bit of like tugging on the sun. So the sun is not perfectly still. It's actually sort of like swaying a little bit on its orbit. So it does move more than an inch, even right now. So we don't really see a difference because an inch is so small compared to the entire size of the sun. But that little dance is actually something that we can study in other stars, and it tells us that they have planets around them that are pulling on that star. So if you see a little star swaying like that, you might have just discovered an exoplanet.
Cool.
Okay.
Can we have
Thank
one
you.
more?
Okay, one more. Why not?
There you go.
How long have you been studying the planets?
So I have been an astronomer. Oh God, I have to like think about how long I've been in this field for about 18 years. So longer than you've been alive. It took a while, and if you love astronomy, you have to usually stay in school pretty long. But I love school. I really enjoy school, and I still work at a school. I work at a university. So it's been about 18 years that I've been studying the stars.
Thank you.
All right. Well, thank you so much. I'm going to start off with a shout out to our classrooms. Thank you for those great questions. Thank you for being with us today on camera, on YouTube, and a shout out to the classrooms who are going to join us a little bit later as well with the recording. It's always great to have you with us. Nathalie, a huge shout out to you. We always love learning about the James Webb Space Telescope. Exoplanets are pretty cool. We're finding more and more, so that's pretty exciting. And maybe, Nathalie, in your opinion, unofficial opinion, what do you think? Are we alone, or do you think there's life elsewhere in our galaxy, universe, and beyond?
I absolutely think that there is life out there. We just need to work very hard to find it. If there was no life out there at all, it would be a big waste of space.
All right. Well, Nathalie, thank you so much for being with us today. Thank you to our classrooms. We hope to see you in future events coming up over the next few weeks. But for now, we are going to sign off. Thanks so much, everyone.
Bye.